Welcome to the lecture on Chapter 3. We're going to be talking about the fundamentals of firewalls. Next, Chapter 3 and 4 will be dealing with firewalls. This week, just the fundamentals. Next week, a little bit on the implementation. So we're going to explain how firewalls work, evaluate different firewall solution, maybe differentiate between packet filtering and a stateful packet filtering. Talk about the definition between those. Maybe differentiate between application and circuit gateways. Look at understanding host-based and router-based firewalls. So firewalls are basically one of the fundamental devices to secure a network. We're only going to cover about the basics, but next chapter we'll talk about how to do some more detailed implementation. So here we hope to, once we understand what choices, now we can make choices as to which one is appropriate for us. What is a firewall? It's basically it's a barrier between the outside world and your network. And it provides security by either filtering packets, stateful packet filtering, which we'll talk about shortly, maybe user identification, or maybe even which applications are running. So it takes data in, does some sort of filtering based on your firewall configuration, and then passes the filtered network packets out to the rest of the world, or out to your network. Now, there are 4 different types of firewalls. There's packet filter, application gateway, circuit level gateway, and a stateful packet inspection, and we'll go into those shortly here. So a packet filtering firewall, it's the very basic. It may also be referred to as a screening firewall, and it basically examines every single packet coming to your network on one of several different types of information, whether it's a source or destination IP address, source or destination ports are coming from. The different protocol. Is it a ping protocol? Is it an internet protocol? So it'll, based on what rules you want to filter, each packet measures against one of these criteria you set, and then either allows it or denies it to get into your network. Now, there are several common packet filtering products. Here are 4 that you can play with. Let me just slide this out. I guess, I don't know, get that out of my way. Oh, wow. So you take a look. The links are in the textbook as far as if you're interested in looking at one of the common packet filtering protocols. Now, the disadvantage, it doesn't compare any packets. Packet comes in, checks it against the list, lets it go through, or denies it. It doesn't compare if 10 packets come in with the same data. It's checking each one totally identical. There's no authentication, and it definitely can be susceptible to an SYN or a ping flood attack. Doesn't track any packets. It just says, it looks at the data, moves on. Because it doesn't even look at the data in the packet. It just says, I'm looking at the header, I'm looking at addresses, protocols, and I don't even care what the data has. So not necessarily the most secure firewall that you can have. Now, if you're going to do, because it's inexpensive and it probably applies to most of us at home, there are things that you should cover. You should make sure that the rules you're setting up for that packet filtering firewall is what protocols to allow. Whether it's FTP, that's just a file transfer protocol, whether I'm doing a ping, whether I'm doing certain email protocols, which ports to allow, which destination, source and destination ports, and which addresses, IP addresses. So you want to make sure that if you're going to set up rules for this, these are the key things you want to make sure your rules take into consideration. Now, a stateful packet inspection, now it's being aware of the context of the packets. which makes them less susceptible to flood attacks. So that means it's checking if packet 1 and packet 2 are related or not. So if all of a sudden I get multiple packets from the same IP address or port number or protocol, now it says, now it can tell, am I being attacked or not? And it can look at the contents of the packet. So when possible, guess what? This one would be the one you want to recommend, especially on the low end markets. Maybe not industrial grade, but your home site, if you can do a stateful packet inspection, that'd be the recommended solution to go with. Some of the examples, Cisco Linksys, SonicWall, are all have products out there that allow to do stateful packet inspection. Now, an application gateway could also be known as an application proxy or an application level proxy. It examines the connection between the client and the server, and then enables the administrator to specify which applications they're going to allow in their network. And it also allows for user authentication. Now, disadvantages, definitely takes more system resources. It's still susceptible to the flooding attacks. Just due to the amount of time it takes to authenticate the user, maybe enough time to flood and makes your router, unavailable, just can't handle. Because when that connection's being made, packets are not being checked. Some products, there's a couple of out there that you can research. I'm not going to ask you to do it for an assignment or anything, but if you're interested in application gateway, you may want to look at it. The fourth one is a circuit level gateway. It's definitely more secure than application gateway. It's typically implemented only on the high-end equipment. It authenticates the user, and a virtual circuit is used to pass data between the client and the proxy server. So they really don't see the internal workings of your internal IP address scheme. External systems don't see internal networks, and may not work for some implementations. So it just depends on what you're doing. And here's an example of one that would give you a little bit more information on a circuit level gateway via software. Usually you see them implemented hardware, but there is some software ones out there. Just to give you a rough idea, if I'm comparing those two applications, circuit level, like I said, the big key here is user authentication, and then the proxy getting to the address. It's a virtual circuit, so all the IP addressing is hidden from the outside world. Where your application, the application's verified, but the user not. So I've pretty much let people in without completing the verification. Now, there are some hybrid, and they're becoming more and more popular, and they take, just multiple approaches to their firewall implementation, where you can do stateful, the SPI version, or circuit level gateway might be used together in some of these situations. Now, how do I implement some of these? Well, one, you got to understand the relationship to the firewall and the network you're trying to protect. Some of the most common solutions are networked host, dual home, router-based, and screened host. A network-based network host base is software that's run on top of the operating system. Now, to make it really secure, what you got to do is harden your operating system, and you can do that by making sure that all the patches are updated, uninstall any unnecessary applications or utilities, close unused ports, and then you want to make sure you turn off services that you're not using. It's a cheap solution, but to really make sure it works, it's this hardening of the operating system. Later in the semester, we'll go into how to go about hardening an operating system. In practice, what happens, at least in the corporate environment, you're creating two separate firewalls, an outer firewall and an inner firewall. The outer one faces the outside world. The inner one faces your internal network. Your web, email, file transfer protocol servers are located in the DMZ, So I don't need to get, so I don't have to free up my vice presidents, sales and marketing, are all hidden down here, but email, web can be located in between the two firewalls. So that's what you see most companies doing. Now, an expanded version of a network host, and it's really only used, it's an older technology, and it's only used if you've got multiple network interface cards. Your server has 2 ports that you're trying to kind of take care of. It still runs on an existing operating system, but the disadvantage with a network host is it's relying on the security of the operating system. So if you're not hardening the operating system, but basically the key is it's not used very much. The key is it's got 2 interfaces versus dealing 1, and most people do not like this one at all. Now, router-based firewall, it's usually the first line of defense. It uses simple packet filtering, can be pre-configured by the user, and it can be placed in between networks of your segment, of different segments of your network. Your home router is probably something you could probably set your wireless router at home, or at least your router as you get into the ISP. You can set this being your first line of defense, and then a second one internally. We'll talk more about that in chapter 4. Now, a screen host is kind of a combination of firewalls. You've got what's called a bastion host, a host that interfaces to the internal network, and you've got a router that's just screening information from the internet. So it's kind of similar to a dual home network, but now I don't have 2 interfaces, I only got 1. So it's not too bad. Now, for the utmost security, you want to make sure you put multiple firewalls in place. Probably a stateful packet inspection firewall along with an application one. A screen firewall routed on different segments. Maybe a dual perimeter screening routers and individual packets. So you want to make sure you have multiple layers. Of course, being the utmost security, that makes it the most secure, but there's an expense and an overhead as with implementing any new software. Now, how do I select and use a firewall? Well, one, you got to make sure you configure it properly. And you may want to consider, maybe not this line here with consultant initial setup, more probably for an industry-based versus a home-based. One you want to do is, as an administrator, you want to make sure you're reviewing your logs. Each of your routers, each of these firewalls create logs on traffic, and you want to make sure you look at them to see, am I noticing any abnormalities that are occurring? And what you want to do when you first set up your network, you want to run this for a week or so and baseline how your network is performing so that you've got something to compare to. Am I seeing an uptick in traffic? Am I seeing an uptick of unusual protocols coming in? So you want to baseline your performance so you've got something to compare to. And then if you make changes, then you reestablish that baseline because you want to make sure you got a baseline, you got to see some problems, implement a problem, compare it to implement your problem, your solution, and then compare it to the baseline. Did it help? If it helped, now establish a new baseline for your next modification. Now, using proxy servers. Now, proxy servers prevent the outside world from gathering information of your internal network. They provide valuable log information. They can redirect traffic based on however you set up your configuration. Typically runs on a firewall machine, so it's a physical machine, and it definitely protects against spoofing that we talked about last chapter. Now, one of the proxy servers here is Wingate Proxy. It's one that you can download and get a free sample for 30 days and to play with it. We'll have to see. I may play with it and see if I want to implement it in the future, but we'll go from there. So now, what's usually most people have gotten away from the proxy servers is network address translation. Now, you remember from your, hopefully from your, probably your Net 126 class, is network address translation takes a private IP address, an internal private IP address, to a public address that can be routed on the internet. And so it maps these internal addresses to a public address. Now, there's several different ways of doing that, but it at least isolates it that, like if I look at school, I probably got one public address where we've got a lot of private addresses allowing network traffic to handle inside the school here. So in summary, you've got firewalls and proxy servers are critical for network security. There's tons of solutions out there. All of them vary in price and features. And you just got to make sure you choose one that, how much money you want to spend. So hopefully you remember you've got different types: packet applications, circuit level, stateful packet inspections, and the different types of implementation. So I got types of firewall, and then how are you going to implement it? It's going to be on the router and network, or you're going to have, kind of do a homed screen up. So hopefully that helps cover a little bit of the material in the chapter. Make sure you read the material, do the homework, and if you have any questions, let me know. Talk to you later. Bye-bye.